Okay, if I remember right, the last thing we were doing was this chemical composition of bone matrix. We already done this stuff, so I remember watching the movie, the Children of Glass movie, where we talked about osteogenesis imperfecta. But remember the bone matrix. You've got the kind of famous inorganic part, or that's the calcium, but you've also got the less famous but important organic part, and that's called the osteoid. There, I remember right here we wrote one of the main components of it was collagen, and it gives bones a little bit of flexibility there on function. And remember with osteogenesis imperfecta, it's a inherited disorder, but it results in problems with the collagen in bone, and it makes them brittle. Remember, it's bone making not right. Yeah, and we watched that video on YouTube called "Children of Glass." Okay, so I don't think we did this. So the inorganic parts. Remember, just a little while ago I said calcium, and that's pretty much true. Here's the official term. I'm going to cut and paste it in. So yours says your notes. Inorganic components consist of calcium salts, chiefly composed of calcium phosphate. Is what you guys want to write right there. Calcium phosphate. So I mean, it's good to have a little bit of give in your bones, like we set up here, but you don't want to have like noodle bones. So what the calcium does is function. Oops, dang it, wrong thing. I'll just type it in. Makes bones sturdy, tough, sturdy. You don't want them to be like noodle bones. So the calcium helps make them pretty solid and tough. Okay. Delete. Osteomalacia and rickets. So we did rickets back in skin chapter. Cause remember, it's a deficiency of a vitamin you make in the skin. You guys remember what it is? Vitamin D. So it's a vitamin D deficiency. And the difference between rickets and osteomalacia, go ahead and write this over here. I'm not going to write it. You guys can do it. But underline rickets. And down below here, write kids. Kids get rickets. Adults get osteomalacia. So underneath, and it's pronounced osteomalacia. It means soft bones. But anyway, this is the adult version. So I don't know if you guys remember. Here, let's see if I can pull this picture up. Make it a little smaller. There we go. You guys remember we looked at that picture? Those are some kids from back, like early 1900s. But as they start to, as they don't get enough vitamin D, they can't absorb calcium out of their food, in their diet. And if you can't get calcium into your blood from your whatever you're eating, you can't get it into your bone, and your body pulls it out of the bone eventually. And you get weak bones. So here you can see the weight-bearing bones of the leg start to warp. For adults with osteomalacia, we don't get the warping of the bones. There's other symptoms. There's like bone pain and easy to get fractures and stuff like that. But our bones don't bend. We just have kind of a different chemical composition sort of than the kids do. All right, so anything else we need right here? All right, so it's vitamin D deficiency. And we kind of already did it, so I'm just going to leave it at that. All right, so let's go to bone development. Okay, so remember we just said it. Osteogenesis imperfecta, bone making not right. So this is just bone making when it is right. Osteogenesis, bone making. Okay, so bone formation during development. There's two ways to do it. Hey, you might want to number this or something. I should have put a number here. Anyway, whether you do or not, there's two ways. Number one, intramembranous ossification. And then down here, if you want, number two, endochondral ossification. So this means inside a membrane, intramembranous, and this means endochondral, inside a. You guys remember what chondro means? Anytime you see chondr or chondro on a word? Cartilage. So if that popped in your head, awesome. If that didn't pop in your head, underline that right there and write cartilage down here. Chondro is one of those terms you need to know. Okay, so let's go back up here. Intramembranous ossification. Developmental pathway for flat bones. So, guys, remember flat bones is what we had on bone test 1. Ribs, sternum, stuff like that. Most of the bones of the cranium, too, are considered kind of flat bones. But the way you do it It's for reasons I can't exactly explain to you. You can't make bone out of the blue. Your body never does that. It's always made from some other kind of pre-existing tissue. So when you're first developing these flat bones, the first thing you develop is this stuff called mesenchyme. It showed up in your homework. It's like a embryonic fibrous connective tissue. And then that becomes ossified, turned into bone. And then so basically, here's what you want to write here. Connective tissue becomes ossified, spongy bone. So remember we passed the bones around in class last week, and we saw the inside of the bones. It mostly has a spongy looking stuff on the inside, and all those flat bones are all spongy on the inside. And on the outside, though, they have that very thin veneer of solid bone. So here it says at surface there is additional ossification. So there's where you want to write this. Remember that stuff's called compact bone. All right, so there's how you make your flat bones. Endochondral ossification, developmental pathway for long bones. So this is the stuff we're going to have whenever we can do it on bone test 2. The appendicular skeleton, arms and leg bones, stuff like that. So I don't think it's anything you got to write right there. So just go to the next page. All right, so when you make these long bones, you still start with mesenchyme, but there's a middleman between mesenchyme and bone. The first thing you do is convert it into a hyaline cartilage model of the bone, and then you convert that over into bone tissue. So way early, early in embryonic development, like a fetus has got like a humerus and a femur, but there's no bone in it. It's all made out of hyaline cartilage. But and then you turn it over into bone. So you do and if you don't remember this, the diaphysis first, and then I put epiphysis singular. It's epiphyses plural. But remember, if you don't remember, the diaphysis is the shaft of a long bone. And write that down if you didn't remember it. So diaphysis first. The shaft gets ossified first, and then later, remember, the epiphyses are the swollen ends. They go later. And anything we got right there, other than what those means if you don't remember? No? Okay. I think that's good. All right. So note, typical long bone structure at birth. Check out this picture of a kid. It's kind of small, but I can't really. That doesn't really help to make it bigger. This is a baby's knee. So if you look, it looks like there's a giant gap right there. So there's not. The actual quote unquote bones, the tibia and the femur, they hook up in the knee joint here, but only the shaft is really made out of bone. The epiphysis, here the distal and here the proximal, or the opposite. Oh yeah, that's it, right. The distal further out on the femur, proximal closer in on the tibia. They're made of cartilage, and if you guys remember looking at the growth plates on the bones last week, when they were hyaline cartilage too, you don't really see them on an X-ray, so it just looks like there's a big gap in there. So by the time of bone, your shaft, your diaphysis is made out of bone. By the time of birth, the diaphysis, the shaft is made out of bone, but the epiphyses are still cartilage. Now, he is starting to turn these over, she, whatever this baby is. If you guys look, there's a white spot right there. That's an ossification center. So, and then as time goes on, that'll proceed and it'll develop into a bone that just has growth plates. Like here, we're gonna look at this picture. It's not a good picture. This kid's got growth plates right there. This is also a baby's bone. Not exactly what I'm about to show you. All right, so typical long bone structure at birth, and here's where we want to write diaphysis bone, epiphyses cartilage. All right, so diaphysis bone, epiphyses are cartilage. And then those get converted over into bone. So here it says in children, the hyaline cartilage persists as the growth plates, or the epiphyseal plates. By the time you go to kindergarten anyway, that's mainly turned over into bone. You've got that growth plate, and you keep that growth plate until those seal up, when you're a teenager. And then you got the epiphyseal lines. All right, bone growth and epiphyseal plates. Here, I'm going to cut and paste here. It's length. Length. I should have just typed it. That's where long bones get longer. How do bones grow in diameter? Okay, so even though I mentioned in class, once those plates seal up, we're not getting any taller. But bones can still grow in diameter. So like if if you're 20, your plates are sealed up and you're not going to get any taller. But if you start working out, have your muscles put stress on the bones will still thicken in response to that stress. So here's how they do that. So go down here. How do bones grow in diameter? I'm just going to paste it in. Osteoblast in the periosteum add new matrix to bone surface and thicken it up. If you need to pause the video or whatever to write it down, go for it. And some stuff to write down if you don't remember it. What that is. Remember the bone-making cells. If you don't remember what that is, remember that's the bone wrapper. All right, calcium homeostasis. Remember what that means? You guys had to define it on the first test, and like almost everyone got it right. Remember, to do it in one word, it means like balance. Remember, keeping things kind of equal inside the body. So we're going to balance our blood calcium levels here. We got a couple different hormones that are going to do that. You guys don't have to worry about this value. I just put it on there so that your normal blood calcium, what's 9.2 to 10.4 mg/dl milligrams per deciliter. It's a tight range, and your body's got to keep it in that pretty tight range. You start to get some pretty serious problems if you get outside of that. So anyway, here's some of the hormones that help regulate it. Calcitriol. This isn't exactly true, but it's pretty much true. Calcitriol is pretty much just vitamin D. So put in vitamin D there. It's the active hormone name of it. But remember, we make vitamin D in the skin, and then the liver and the kidneys converted into calcitriol, the hormone. But calcitriol, it's a better name really as a hormone than vitamin D is, because it lets you know what it acts on, calcium, and it's a steroid all. But remember that we were talking about rickets a little while ago. Those kids that can't absorb calcium. But calcitriol allows you to absorb calcium out of your food. So here's what you want to write down here. If you're absorbing it out of your food, you're putting it into your blood. So this is going to increase blood calcium levels. And if you got plenty of calcium in your blood, you can put plenty of calcium in your bone. You ain't going to get rickets if you're a kid. All right, calcitonin. Produced by the thyroid gland. If you know someone's got thyroid problems, it's probably not this hormone. There's another hormone aptly named thyroid hormone that usually does that. But check this out. So remember, we're in the homeostasis and balance. So, wait, all right. Oh, here. Okay. So thyroid gland, this is secreted when blood calcium levels are high. So if blood calcium levels are high and you want to balance them out, you want to send them down low. So I'm going to cut and paste. Is what you want to do here. Or wherever you want in here somewhere. I'm just going to paste it in there. So it's going to decrease blood calcium levels, and so if you're getting up too high, it wants to bring it back down. But remember, there's not any magic tricks here in physiology. It's not just going to vanish or something. So if it's going out of your blood, it's going into bone. And down here, check out the way it does that. It turns off the bone destroyers, and it's going into your bone because it stimulates the osteoblast, the bone-making cells. All right, and these videos got to top out at 15 minutes, so we're going to hold off right there. There's the end of part 1.